Good morning to everyone. Today I am going to present my exhibit. My exhibit name is Journey of Light from Mirror to Rainbow. In this exhibit I am going to explain you about 4 different topics of light. Reflection of light, refraction of light, total internal reflection of light and dispersion of light. First of all, let me explain about reflection of light. Reflection of light means bouncing back of light when it strikes a surface. When light rays strikes a shiny surface like mirror, it reflects back. This is called reflection. There are 2 important laws of reflection. The first law of reflection is angle of incidence is always equal to the angle of refraction. Let me show it. This is incident ray. This is reflected ray. The angle which incident ray makes with normal is called incident angle of incidence, and the angle which reflected ray makes with normal is called angle of reflection. Now the incident ray is making 40 degrees with the normal. So the reflected ray will also make 40 degrees with the normal. If it makes 20 degree, the reflected ray also makes 20 degree with the normal. This shows that angle of reflection is always equal to the angle of incidence. The second law of reflection of light is the incident ray, the reflected ray and the normal all lie in the same plane. Reflection of light is very important in our daily life. Without reflection, we cannot see nothing around us. Now, let me explain about refraction of light. Refraction of light means bending of light when it passes from one medium to another medium. For example, when light ray passes from rarer medium like air to denser medium like glass, it bends due to the change in speed. This bending of light is called refraction of light. The daily life examples are: a pencil looks bent when it is in glass of water. There are 2 important points in this topic. The first point is, if a light ray goes from rarer medium to denser medium, it bends towards the normal. The second point is, when a light ray passes from denser medium to rarer medium, it bends away from the normal. Now a question might arise: what is rarer medium and what is denser medium? Rarer medium is medium with less density, while denser medium is a medium with more density. Let me show this with the help of an experiment. If a incident light ray, it should go straight to like this, but it will bend. This is rarer medium, air. This is denser medium, glass. A light ray is coming like this. Now, the light ray isn't going straight. It's just bending towards the normal. As I said, when light ray passes from rarer medium to denser medium, it bends towards the normal. Now, light ray is going out of the denser medium. So, it's bending away from the normal. Applications of refraction of light in our daily life are cameras, lenses in spectacles, telescopes and microscopes. Refraction helps us to understand many natural phenomena and is very useful in making optical instruments. Now, let me explain about total internal reflection with the help of these 3 diagrams. Diagram 1. In this first diagram, a light ray traveling from a denser medium like glass to a rarer medium like air. The light ray strikes the surface. It bends away from the normal. This bending is called refraction of light. Here, the light does not reflect completely. It only changes its direction and passes into the air. Now, diagram 2, critical angle. In the second diagram, we increase the angle of incidence slowly. At a particular angle, the reflected ray travels along the surface. This angle is called critical angle. So, critical angle is the angle of incidence in the denser medium for which the angle of refraction becomes exactly 90 degrees. Now, diagram 3, total internal reflection. In the third diagram, the angle of incidence is greater than the critical angle. Now, the light does not come out. It reflects completely back into the denser medium. This phenomenon is called total internal reflection of light. If we prolong this to 10 meters, the light will reflect 10 meters inside the denser medium. Here, the 100% of light is reflected inside. This is total internal reflection. Conditions for total internal reflection are the ray should travel from denser medium to rarer medium, and the angle of incidence must be greater than the critical angle. Applications of total internal reflection in our daily life are optical fiber communication, endoscopy in medical field, and diamond sparkle. Using this semicircular glass slab, we observe how light reflects inside a denser medium. The total internal reflection is very important topic in physics and has many real life applications in our daily life. Now, let me explain briefly about one of the examples of total internal reflection. It is optical fiber for internet communication. Optical fiber internet journey. First, the data signal goes from user device to OLT, which is optical line terminal. It transforms electrical signals to light signals. Then it goes to optical fiber cable. This passes the light signals to ISP through the method of total internal reflection. ISP means Internet Service Provider. Here, the light signals again transformed into electrical signals. Then it goes to global internet server, where this data is provided in global internet. Now, let me explain about dispersion of light. Dispersion of light means splitting of white light into its 7 colors when passed through a glass prism. What actually happens in this experiment? When white light from sun or torchlight passes through a glass prism, it bends due to refraction. But here, something special happens. The white light is actually made up of millions of colors. But we accept 7 colors primarily. They are violet, indigo, blue, green, yellow, orange and red. Each color has different wavelength and speed in glass prism. So, each color bends in different amounts. The violet bends the most and the red bends least. As a result, white light splits into 7 different colors. This splitting of light is known as dispersion of light. This dispersion of light happens because different colors have different wavelength. The refractive index of glass is varied for each color. So, each color bends differently. Real life example for this dispersion of light is rainbow. The little droplets of water acts as mini prisms and disperses the white light into 7 different colors. So, dispersion of light shows that white light is a combination of many colors. The small prism helps us to see the beautiful spectrum of colors for light. Thank you.